Namaste to everyone. I'm Matrices, Mathematics department. See, in the last two sessions of matrices, we learned about the finding the inverse of a matrix using elementary transformations for a 2 by 2 matrix and same as for 3 by 3 matrix also. On that day itself, I told you to solve the rest of the questions. So in the session 2, we discussed about the finding the inverse of a matrix 3 by 3. I solved the question number 15. And there are rest of our questions, question number 16 and question number 17 I told to solve you. And in the first session I discussed about the 2 by 2 matrices finding the inverse. There are 14 questions. I told to try to solve the 14 questions, but I hope many people done the questions. But in those 14 questions there are two different questions. There are question number 12 and question number 14. For those questions you may face difficulty to find the inverse. So now look at the question number 12 and the question number 14, how to solve. See the question, if you see the question properly, the question is using elementary transformations find the inverse of each of the matrices if it exists. If it exists means it doesn't mean that every matrix will have an inverse. Okay, some matrices may have, some matrices may not. Okay, so for the 14 questions except 12 and 14, every matrix will have the inverse. So for those questions you no need to get any difficulty or no need to face any difficulty to find the inverse of the matrices. But coming to the question number 12 and question number 14, these are the different questions. In this session I want to explain those questions. So question number 14. So what is the question number 14? Question number 14, the given matrix is 2 1 4 2. See, question number 14, solution I am taking. Let the given matrix capital A is equal to 2 1 4 2. So we know that we can write any matrix as a product of identity matrix I2 into A. So left side 2 1 4 2 and the right side instead of identity matrix we can write 1 0 0 1 into A. So now we will solve the question. See, based on the first diagonal entry we are supposed to make the other entry in the column as 0. So performing R2 changes to R2 minus 2 R1. R2 changes to R2 minus 2 R1. Then what you will get? First row there is no change, 2 1. Second row 4 minus 2 into 2 and 2 minus 2 into 1. That is equal to the same operation we have to apply on the right side also. So first row there is no change. Second row R2 0 minus 2 into 1 and 1 minus 2 into 0 into A. So if you simplify it, you will get 2 1 0 0 is equal to 1 0 minus 2 1 into A. So if you observe it, here the second diagonal entry becomes 0. So if the second diagonal entry becomes 0, we can't convert it into 1. Is it clear? So that's why for this question the inverse of the matrix doesn't exist. Is it clear? So the inverse of the matrix doesn't exist because the second diagonal entry here it is 0. Okay. In the same manner for the question number 12 also you didn't get the inverse because in that question also if you apply any elementary transformations one of the diagonal entry becomes 0. So to convert the given matrix into identity matrix we must have the diagonal entries as non-zero entries, but here we are getting the diagonal entries as 0, so that's why we can't find the inverse of the given matrices. That's it. Thank you. Have a nice day.